This lesson is on section 4.2, Graphing Polynomial Functions. And before we begin, let's remember that the degree of the polynomial is the highest power of x. So, example, if I have this polynomial listed out, the first term would have a coefficient that would be this a, and then the highest power would be this n right here. And I'm just going to assume that's written in order from highest to lowest powers, which would be standard form. That n also tells us how many zeros or x-intercepts that the graph would have. And here we say at most n, that's the number of real intercepts or zeros. So it could, like if this was a 4, it could have 4 real solutions, or it could have 2 real solutions and 2 imaginary solutions. But at most n real solutions, meaning places that it actually crosses the x-axis. So we actually cross the x-axis that many times, whatever that number is. Again, it doesn't have to because it could have imaginary. That's why they say at most. The other thing that happens that we haven't talked about yet is turning points. Turning points are where we have maxes or mins, but the graph actually makes a turn. So this would be a turning point, this would be a turning point. If the power is n, at most it would have n minus 1 turning points. That means it doesn't have to have that many, but it could have that many. So again, if n were 5, it would have at most 4 turns in the graph. It could have less, but at most it would have 4. The main thing in this lesson that we're going to be working with is graphing polynomials, and we're going to do this sort of by hand, not necessarily on your calculator. We're going to be able to determine lots of things about the graph without typing it in and letting the calculator do the work for us. First step we're going to have is we're going to use the leading coefficient test to determine the end behavior. So we're going to figure out what's happening as x approaches infinity and what's happening as x approaches negative infinity, and that's going to tell us what's happening on the ends of the graph. The next thing we're going to do is find the zeros and plot them on a number line. A lot of times we're going to be factoring to find these zeros, and then we'll be plotting those. And you'll have to remember, if it has a multiplicity of an even amount, then it will bounce off, and if it has a multiplicity that is odd, it will pass through. We learned that in our last lesson. So we're going to be using those two things from our last lesson here. Then what we're going to do is a little different. We're going to use test points between the zeros to determine whether the section is positive or negative. So I'll show you when we get to a real problem what I'm talking about here, but we're just going to determine if the graph is above the x-axis or below the x-axis between zeros. We are going to find the y-intercept to make that specific, and then we're going to find a few more points just to make our graph be as specific as, a little more specific, I guess, than general, because in the last lesson we went very general. And then finally we will sketch our graph. So we're going to do about 3 examples of this. And here's our first one. We have h of x equals negative 2x to the 4th plus 3x cubed. So first of all, our leading coefficient test says that it's negative, and we have that x to the 4th power, so we know that both ends will be going down because it's going to be some sort of U-shape. We don't know what's happening in the middle, but it's facing down. And then our zeros, our second step is finding our zeros, so we will say 0 equals this, but I'm going to go ahead and start to factor. I'm going to take out a GCF of x cubed, and that's going to leave me with negative 2x plus 3. And if I set those equal to 0, I have x cubed equals 0 and negative 2x plus 3 equals 0. And the x cubed equals 0, when you cube root 0, you still get 0, but this does have a multiplicity 3 because that power was a cube here, and it took 3 x's to get, or 3 x's would be answers of 0. Over here, I'm going to solve. I'm going to subtract the 3, so I get negative 2x equals negative 3. And then I'm going to divide by negative 2, and I get a positive 3/2. And that's just multiplicity 1 because I didn't have any powers here. And so those are my zeros. I have 3 zeros and 1 at 3/2, which is 1 1/2. And if I think about making a number line for that right now, I have 0 here, and I have 3/2 here. And again, that multiplicity 3 means the graph will go through, so we should be changing signs, which is part of our next thing. Our next thing is using test points. And by test points, what that means is you can pick anything before 0 and plug it into the function and decide whether it's going to be positive or negative. You can pick anything between 0 and 3/2 or 1 1/2 and see the same thing, and then anything past this. So I'm just trying to figure out which sections are above and which sections are below. So I'm going to come over here for H, and I'm going to pick anything before 0, and I like to choose easy things. So something before 0 that's easy to work with is negative 1. So my test point is going to be at negative 1. If I plug in negative 1, I get negative 2 times negative 1 to the 4th plus 3 times negative 1 cubed. And negative 1 to the 4th will be a positive, so I end up with a positive 1 times a negative 2. Negative 1 to the 3rd will be a negative, so I have a negative 1 times a 3. And so I end up with a negative 5. And I'm not so much concerned about what the number is right now, just the fact that it's negative. So in this section of the graph, before 0, my graph's going to be negative. In other words, it's going to be below the x-axis. But I kind of write them up here to remind me. And then next one, h of something between 0 and 3/2, which is 1 1/2. Obviously, the easiest thing to me is going to be a 1. So I'm going to plug in a 1. Negative 2 times 1 to the 4th plus 3 times 1 cubed. So again, I get a positive 1 here times a negative 2. And here I get a positive 1 times a 3. So I end up with a positive 1. And so this section will be positive because even though I just plugged in 1, that means anything I plug in between these should give me a positive answer. And then our last section, something past 3/2, past 1 1/2, so I'm just going to choose 2 because I always go for the easiest, but you don't have to. Negative 2 times 2 to the 4th plus 3 times 2 cubed. And that's going to give me a negative 8. So I know that anything I plug in past 3/2 is going to be negative. So this is kind of what I get for my signs. Let's figure out the y-intercept. Our y-intercept you get from plugging 0 in for x. So if I say negative 2 times 0 to the 4th plus 3 times 0 cubed, in both cases I get 0. So my y-intercept is 0, 0. Now, I know a lot of points already. So if I make a list, I know I have 0, 0. I just found that. I know I have negative 1, negative 5, and 1, 1, and negative, 2, negative 8. Let's find a couple more points just to make this nice and clear. So I have, let's pick a negative 1.5 and a negative 0.5 and 0.5 and maybe 2.5. Okay, and so I'm just going to get the outputs for each of those. And so I'm going to plug each one into H and see what I come up with. And I get 20.25, negative 0.5, 0.25, and negative 3.25. So I'm going to use these, and I'm going to use this number line and the end behavior and sketch a graph. So I'm going to pause for a minute and erase this work, but you can probably fit it below. I just want you to be able to see the graph with what we have learned. Okay, so now I have a graph ready to go, and you can probably use graph paper to do this a little better. So you can grab a piece up at the front. I'm going to plot each of these points. So I have 0, 0. Before I continue on, let me go over here. Our zeros were at 0 and at 3/2, so 1.5. I know I've got to go through those points. I know I'm going to be negative before, positive between, and negative after. And that should make the ends both point down like I had planned. So again, I'm going to plot -1, -5. I'm going to plot 1, 1. I'm going to plot 2, -8. -1.5 at 20. That'll be off my screen. But if you have graph paper, you might can hit that. And then -1/2, -1/2. And 2.5. Sorry, that was supposed to be a 31. -31. Again, is off of my chart. So I can do a pretty decent job of coming up and getting the shape of this graph right. And if you want, you can graph it in your calculator and check. But the big thing today is learning these steps by hand. Let's move to the next example. Okay, my leading coefficient test on this one, this is an x-cubed graph and it's positive, so that means that the left end will go down and the right end will go up. I can find my zeros in this case by factor by grouping. So I'm going to group the first two together and the second two together and take out GCFs, so that'll be an x squared here and a -4 here. And then I have a GCF of 2x plus 1, and that leaves me with x squared minus 4. So I can set 2x plus 1 equal to 0 and x squared minus 4 equal to 0. Here I'm going to subtract 1 and divide by 2. Over here I can either factor into x minus 2 and x plus 2, or I can use the square root method and remember to do both positive and negative answers. And so x will be -2 and +2, either way you do it. And so if I do a number line, my zeros should be -1/2 and -2 and +2. And again, this is not my final graph, so I'm just showing the 3 sections here. And now I'm going to do test points in those sections. So f of something before -2, I'm going to say -3. I'm going to choose something between -2 and -1/2, so -1. And then I'm going to choose something between -1/2 and 2, which would be 0. Be a good one to use. And then something after 2, and again I'm going to choose 3. I always like to choose easy numbers, but you can choose any number in that section. You could have chosen 1 in this -1/2 to 2 range. Okay, when I plug those in, I got these answers, which tells me before -2 I'm negative, between -2 and -1/2 I'm positive, between -1/2 and 2 I am negative, and then after 2 I am positive again. And so I have a list here of some of my values. I know -3 comes out 25, I know -1 is 3, I know 0 is -4, and I know 3 is 35. I need to find my y-intercept by plugging in 0 for x. So 2 times 0 cubed plus 0 squared minus 8x minus 4, and I should put a 0 in for that x, gives me a -4 that was 0, -4 was my y-intercept. And then the next thing is I'm going to add a few more points on. I'm going to add on 1 and maybe -2.5 and 1/2 and 1.5. So if I plug in a 1, I get out -9. If I plug in -2.5, I get out -9. If I plug in 1/2, I get out -7.5. And if I plug in 1.5, I get -7. So now I can use these to sketch. Okay, so now I'm ready to graph. I know my zeros are at -2, at -1/2, and at +2. I know my ends should go down and up. I know I should be negative, positive, negative, positive. So now I'm going to plot my points. At -3, I'm at 25, which I think that was supposed to be a -25, and it was. At negative, and that's off my screen. So at -1, I'm at 3. At 0, I'm at -4. At 3, I'm at 3.5. Or is that 35? That's 35, sorry. So that's off my screen. At 1, I'm at -9. And at -2.5, I'm at -9. And at 0.5, I'm at -7. And at 1.5, or excuse me, I'm at -7.5. And at 1.5, I'm at -7. And now I can connect, and it should follow all the rules that I have decided that it should. And doing the best I can. It's a little bit sketchy, but you probably can do a little better with some graph paper. And there's our graph. Okay, in this third example, we are doing an x to the 4th, and it's very long, and this would have been impossible to think about almost. Factoring, I mean, it's possible, we just haven't went over that in this class, and they have it factored for us, so occasionally things will be factored for you. By our leading coefficient test, because this is an x to the 4th and it's positive, we know it's going to face up on both ends, we just don't know what's happening in the middle. Our zeros, if I set this equal to 0, I can get x plus 1 equal to 0, x minus 2 equal to 0, and x minus 4 equal to 0. Notice that since this is squared, this answer will be a multiplicity too. So x will be -1, +2, which should be multiplicity 2, should bounce off, and x equals 4. So if I'm plotting my number line, -1, +2, and +4 are where I should cross through. And then because of that, I'm going to find g of something in each category. My g's are starting to look like 6s, sorry. Something before -1, maybe -2. Something between -1 and 2. I can choose 0. Sometimes you could choose 1, be fine. Something between 2 and 4, 3. And then something after 4, like 5. Okay, so I plug those in. I got these y values. I am also going to make a table and choose a few more to find. Okay, so I picked some x values and I plugged in to find out what those y values were. And now I'm going to sketch my graph. Okay, so I'm going to start with my zeros. I have -1, +2, and +4. I know both ends should end up. So I have the point -2, 96, which 96 will be very much off of my page. The point 0, -16, which again is off my page. But you can probably fit that on a graph paper that you have. 3, -4. so about right here, and 554 would be again off my page, so negative 1.25, 13.9, maybe somewhere up in here, and then 1, negative 6 right here, and 2.5 and negative 1.3, and 3.5 and negative 5.1, and so, okay, it's going to make a big dip right there. All right. So if I go to graph this, I mean, I knew I was up off the page here, but the end was up. And I've lost my negative 16 was off my page, so I can't even show you that. If it was down at negative 16, hopefully you have it on your graph paper. Then we would come up through, we would bounce off at 2 because it has multiplicity that was even, and that makes sense with the points that we have, and then the other end should end up just as we predicted. Okay, the second thing you're learning about today is the intermediate value theorem, and it says if a and b are not equal, and a and b are representing x values, so somewhere on a graph a and b, p of a and p of b have different signs, so these are the y values, there must be a real zero between a and b. P of A and P of B have different signs, meaning one's positive and one's negative. So let's just make some kind of graph where at A, this would be the y value P of A, and at B, this would be the y value P of B. And so what this says is if this is a polynomial and you have these two x values that are different, one has a y value that's positive, one has a y value that's negative, and it could be flipped the other way, then there has to be a 0 between there. And so that 0 would be right here where we're crossing the x-axis, and they're going to label that C to be that 0. So our questions are going to say, use the intermediate value theorem to determine, if possible, whether the function has a real 0 between a and b. All you have to do is figure out if the two y values have different signs. So for the first one, I'm going to do f of negative 4 and f of negative 2 and figure out what those answers are, and if they have different signs, then it does have a 0. If I plug in negative 4, I get negative 24. If I plug in negative 2, I get positive 8. Because these two have different signs, then yes, it's going to have a real 0 between the two. For B, I'm going to plug in these two that they've given us. So I'm going to plug in the negative 1, and that gives me 6. And then I'm going to plug in 3, and that gives me 18. And these are both positive, so it didn't change sign. You don't have a 0 between them. For C, I plug in the negative 1/2, and I plug in the positive 1/2. Be careful with your signs here. If you plug in negative 1/2, you get 7/48. If you plug in a positive 1/2, you get negative 5/48. And since one's positive and one's negative, yes, there will be a 0 between them. And then for part D, we have g of 1 and g of 2. If I plug 1 in, I get a negative 2/3. If I plug 2 in, I get a negative 8/3. Since those do not change signs, no, there is not a 0 between them. And that concludes this lesson.